Welcome back. In this next section, we are looking at Unit 1, Topic 1, Subtopic Quadratic Functions, which has a suggested teaching and learning time of about 7 hours. To start things off, let's just quickly go back over or have a quick refresher of what is a quadratic function. So up here, I have a fifth order polynomial function. So when you're looking at just a first order function, we end up with a linear equation. So it would have its y-axis, x-axis has something like that. Then we have a second order polynomial function, and this here is our quadratic function. So y is equal to ax squared plus bx plus c, and that's one of the generic forms that you might see this type of function in. Now, instead of having y, you could have f of x. So this states that the variable within your function is the variable x. And so you can sub in x as any given number. But when you're plotting it and you're plotting f of x, you're plotting it for each individual number. So for each individual x value, you're plotting it to give you a y value. And when you plot a quadratic function, you end up with a parabola. So it might look something like this. Y is equal to ax squared plus bx plus c. And your quadratic function could be represented in any of these forms. So all of these are still quadratic functions, just factorized in different ways. So this is the generic form, and then you could have it in the turning point form. So your h and k values would give you your turning point location, or you could have it completely factorized. And these factorized forms, when used with the null factor law, could help you find your zero crossings, or this form here where it's kind of like the turning point form, but you don't have that plus k section. And so this would tell you whether or not you've got a turning point at the actual zero crossing. So for instance, if the function looked like this, you have the turning point there. So that noting that is useful for third order polynomial functions where you've got additional shape to your graph and you're trying to figure out what the graph looks like. So for this topic, you're going to need some prerequisite skills such as collecting like terms, expanding brackets, and factorizing. To begin with, let's look at expanding and then collecting like terms. So let's say we have a question that is 4, then in brackets 2x plus 3 minus 3, 4x plus 5. Now, when we're expanding in brackets, if you have a negative there, that negative is associated with the coefficient out the front, and so it gets expanded into every term as well. So we have this 4 going into this first set of brackets. So we have 4 times by 2x gives us 8x, plus 3 times by 4 gives us 12, minus 3 times by 4x, so minus 12x, minus 3 times by 5, so minus 15. So we've expanded that, and then we collect our like terms. So we can see that we have two terms that contain an x. So we can factorize x out from those two. We have 8 minus 12x plus 12 minus 15. So that 12 is there, that 15 is there. So that 8 minus 12x. So note that minus is still associated with the 12. We have minus 4x minus 3. So we have expanded the brackets and then we've collected like terms. This should feel familiar and you will have seen this in class. I'm just going over this quickly as it is a prerequisite for this content. Next, let's quickly revise expanding two sets of brackets. So we're expanding each term into each other term of the brackets. So x times by x is x squared, x times by negative 3, minus 3x, 3 times by x plus 3x, and then 3 times by -3. So you have -9, where the middle two terms cancel, and we're left with that first term squared minus that second term squared. So remember, this is similar to the form we saw in the surds content, where you have a plus b in brackets and then multiplied by a minus b. Okay, next let's revise a factorizing based question. So with factorizing, we're pulling out common features. So we can see that 6 and 12 are both even, and in fact, they're both divisible by 6. So I can pull 6 out of both of these. We have an x cubed, we have an x squared, so we can pull out up to x squared out of both of these. And both of these have a y cubed, so we can pull that out too. So we have 6x squared, because that's the limit of that one over there, and y cubed. And then, so I've pulled out everything except for 1x in that first term. And we've pulled out 6. So 6 times 2 is 12. So we've got 2 left in here. And then we've pulled out everything else in that second term. Okay, have a go at expanding and simplifying these questions yourself. And in the simplification process, if you can collect any like terms, collect your like terms. So what I've got written here, in case it's too hard to read, I've got 2x and then in brackets x minus 5 plus x in brackets x minus 5. Next line, I have 6x and in brackets 2x plus 3 minus 4, x minus 1. Next line, I have x plus 4, x minus 3. And the bottom line, I have 3 and in brackets 3x minus 8, x minus 4. So have a go at those, and I'll come back in about 10 seconds and we can go through them together. Okay, let's go through this first question. So we're going to expand each of these brackets first. And then once we've expanded, we're going to bring the two lots of stuff together and see if we can collect any like terms. And if we can, we do that. And then after that, we would probably factorize if possible to get it into its simplest form right at the end. So we're expanding this. So we have 2x times by x, so we have 2x squared. 2x times by -5, so minus 10x, plus x times by x, so we have x squared, and x times by -5, so we have minus 5x. So we've got this one line, a whole bunch of terms. So we have an x squared and an x squared that can come together. We have 2 plus 1 x squared. Normally, you wouldn't have to write out this line here where you're factorizing out the x squared. I'm just showing you what you're actually doing mathematically. And then you have minus and minus. So you have minus in brackets 10 plus 5x. So with these two terms, because they both have a minus, you're bringing them together and you're making it more negative. But when you're factorizing, you would factorize the negative out of both of those. And so you'd have it inside as 10 plus 5, because then when you re-expand, it's going to be negative. Now, simplifying this, you have 3x squared minus 15x. So normally you would just go from this line to this line. But again, this just shows you what you're actually doing mathematically. Now, I'm seeing some common features here. So this wouldn't be your final answer. You would want to simplify this. Now, if you hadn't simplified it past this, have a quick go. I'll give you another couple seconds to pause it here. Okay, hopefully you've gotten to the final expression. So we can see there's a common feature of at least 3 in each of these terms. So 3 comes out, and we have x to the power of 1 that's common in both of these. So we'd be left with, after we pull out 3 and one of these x's, we'd be left with x in that first term minus 5 in that second term. And that would be the final answer for that question. Okay, next question. Doing the same thing first. We're expanding these brackets and then we're going to collect our like terms. So we have 6x times by 2x. We have 12x squared. 6 by 3 plus 18x. We have a minus 4 times by 1, so minus 4. And we also have a minus 4 times by minus x. We have a plus 4x because minus times minus gives us positive. Now, again, we're collecting our like terms. So we have two components that have x to the power of 1. So when we're collecting like terms, we're really focusing on um, the terms that have similar x's to the powers. So let's write out this next line. 18 plus 4 is 22x minus 4. And that would be our quadratic function. Now, this expanded form can actually be factorized down into this, but we haven't gone over this just yet. So don't worry if you can't factorize it into this form just yet. We'll go over that in the next video. Now, with the last two questions, they're already starting out in a completely factorized form. So with these, you're just expanding and simplifying. So we want to expand these first. So we have x times by x gives us x squared. X times by minus 3, so minus 3x plus 4x minus 12. And then collecting our like terms, we have two components that have x to the power of 1. So we're bringing the minus 3 and the 4 together. So we have x squared plus x. So we have plus 1x, but whenever you just have the number 1, you don't necessarily need to write it. So we can just write it as plus x minus 12. Okay, again, for this last question, because it's already in a completely factorized form, we're just going to expand and simplify. So um, order doesn't matter. So we could expand the 3 into this brackets first, or we could expand this brackets into this brackets first. The reason I'm saying order doesn't matter is because if you have 2 times by 3 times by 4, you have 6 you have 6 times by 4, which gives you 24. Or you could have 2 times by 12, again, gives you 24. So when you just have multiplication or division between components, order doesn't matter. You get the same result. Now, you may have done a different order to me, but again, we should get the same result. So I'm expanding, I'm just going to go left to right and expand the 3 into the first set of brackets. So 9x minus 3/8 are 24. And then again expand. So 9x times by x, I have 9x squared minus 9x times by negative 4 will give me 36x minus 24x minus minus, so plus. Now, you could try and do this without a calculator. So 24 times by 4, a little bit tricky, but 24 is very close to the number 25. It's just one off. So we could say, well, what's 25 times by 4? Well, that would be 100, but we're going to have 4 less because 4 times by 1 is 4. So I'll just show you the mental math that you could be doing. So 24 is equal to 25 minus 1, right? So 25 minus 1 times by 4 is equal to 100 minus 4. Is equal to 96. So that would be the mental math that's going on to be able to do this multiplication in your head without a calculator. Plus 96. So I'm just going to move down here on the page to make it a little bit neater. So I'm just going to rewrite that last line, 9x squared minus 36x minus 24x plus 96. Now, collecting our like terms, we can have 36x, so negative 36x minus 24x. So we have a negative number, we're making it more negative, 9x squared, 30, 40, 50, 60. So we have negative 60x plus 96. Now we have it in this completely expanded form. And if we wanted to, so this is all I was actually asking for this question, but if we wanted to, and we wanted to keep it in this form of ax squared plus bx plus c, we could factorize out the common factors of just these three terms and still leave it in this form, but leave it in a simplified version of this form. Okay, we'll leave it there for this first video, but then in the next video, we will look at factorizing techniques.